So today we're going to look at another equation of a line, and this equation is called point-slope form. And the reason it's called point-slope form is because in order to use this equation, you need a point and the slope. So those are the two pieces of information that were given to write this equation. Now the way that I set up the equation is the one that I gave to you here. The real mathematical form of point-slope is when both y's are on the same side. So let me explain why I changed this around and why I think it's a little bit easier for you to use. So the first reason I changed it around is so that both the x and the y from the point are in the order you're used to seeing them in the ordered pair. So the first piece you come across is the x coordinate, and then you'll see the y coordinate. And that's exactly the way they sit in an ordered pair, x, y. So first reason is they're in order. The x and y are in order like the ordered pair. The second reason is because I use an asylum analogy when we talk about point-slope form. So I hope that you notice right here, inside the parentheses, the x-coordinate is negative or opposite. So what I do is I call this set of parentheses that's grouped around our x's the asylum. So I want you to think about why people get sent to an asylum. It's because they don't act normal, they don't talk normal, they don't do what we expect them to do. So when that x-coordinate goes inside the asylum, it doesn't do what you expect it to do. It does the opposite. And then on the outside here, we have our y-coordinate, and notice that that's positive or normal or exactly what we expect it to do because it's outside the asylum. So as we get started here using this point-slope or asylum equation, hopefully that analogy helps you to get this organized a little bit better. All right, starting with our first example, we are given the slope and a point. We are going to directly substitute it right into our asylum or point-slope equation. So I'm going to write the equation down for you again. So remember, the x1 and y1 are the points and the m is the slope. So the x and y stay x and y. Remember the y equals mx plus b equation. X and y stay x and y as well. So we've got y equals m is our slope, which in this case is 2/3. X stays x. Now the x coordinate, remember x, y, the x coordinate is opposite. It doesn't do what you expect it to do. So our x coordinate is a positive 9. It goes into our equation, into the asylum as a negative 9. And then our plus y1, the 4, is normal. It's outside the asylum, and it stays the way that we expect it to stay. Step 2, what we're going to do now is put this into slope-intercept form. So in order to do that, we're simplifying this equation by solving for y. So we're going to start to distribute our slope. So the 2/3 times x is just 2/3 x minus, and I'm going to show a little work here when I do my 2/3 times 9. For a lot of you, if you organize it by putting it as 9/1, that will maybe help you multiply a little bit easier. So that's what I'm going to do next, is multiply my fraction and my 9. What I like to do when I multiply fractions with integers is cancel first. For a lot of you, I actually think multiplying straight across and then simplifying is easier. And in this case, the 2 times 9 doesn't get real big. However, if you've got numbers that when they multiply get real big, I would recommend looking for canceling. 3 goes into 9 3 times, so that leaves you with 2 times 3, or 6. And then our last step, we're going to combine those like terms. -6 plus 4 is -2. We're going to see one more writing an equation, this one given a graph, and the steps are exactly the same as they were on the last one. except you have to figure out what the slope and the point is before you can substitute into the equation. So when we're finding slope from a graph, we count rise over run. Make sure you remember rise over run and you don't get your slope upside down. So from these two nice points we're given, I see a rise of 2 and a run of 8. So my slope is 2/8, which of course we always want to simplify our slope. 2 goes into 2 and 8, so it simplifies to 1/4. Next, choose one of the 2 points. Either point, it doesn't matter. In our last example, both coordinates were positive, so this one I am going to choose this point so we can see what happens when we have a negative coordinate. So that is the point -2, 6. And then we can do exactly what we did on that first example. Now we can substitute into our equation, which I'll jot down for you again. And I recommend that you do this too. The more often you write down the equation, the faster you'll get it memorized. So, substituting my slope in for m. Now this time, my x-coordinate is negative. Remember, it goes into the asylum and it does the opposite of what you expect. So it's actually going into my equation as a +2. And then on the outside, we have our +6 because y is normal. It does what we expect it to do. This time, we're not going to simplify and solve for y. We're just going to practice substituting into the equation.